everybody, it's time for lesson 10-4, slope of a line. Now you might be thinking, have you gone crazy? We've already covered this section. The slope that we talked about before was all positive, and we didn't really deal with any negative slopes. You were introduced to the slope formula, but we didn't focus on it a lot. So now we're kind of building on what you know. So you're going to take what you know and apply it to this, and it'll make it seem like a piece of cake. Just don't eat your sheet, okay? All right, so we do remember slope, it's the line that's a ratio of change in y divided by change in x. Rise over run between any 2 points that you pick on a line. So these are all of the different ways you have learned to write slope. You've learned that slope is rise over run. You've learned slope is change in y over change in x. You've learned that you can take y2 minus y1 over x2 minus x1. And we also refer to it as the change in y over the change in x. So all of those still mean the same exact thing. Here I have a little diagram. It says a slope that rises from the left to the right is a positive slope. These are really the only kinds of lines that you have had to deal with. Today we're going to be looking also at lines that fall from the left to the right. Those are going to have negative slopes. And think about it. With this line from point to point is going up by the same amount. When you travel up, that's positive. To get from here to here, we'd have to travel down though. And traveling down, that reflects a negative value. So let's try it. Again, we're going to take what we know. We're going to use this rise over run. And we're going to find the slope of each one of these lines, writing our answer in simplest form. So it doesn't matter if you start from the top down or the bottom up. I know we're used to starting from the bottom up, so I'm fine with that. So on this line here, to get from here to here, I need to go up 2 to get across from it. So that's my numerator, that's my rise. But now to get from here to here, I have to go left 4. When you move left, that reflects a negative movement. So left 4 would mean a negative 4. Now in looking at this, hopefully you see 2/4, that is not in simplest form. The slope of this is 1/2. And this is really a division problem. What we have here is a 2 being divided by a negative 4. Isn't a positive divided by a negative a negative? So instead of putting the negative sign in this denominator, it's usually not written like that. We see it right in the center to represent this is a negative 1/2. So negative 1/2, that makes sense because the line is traveling downward from the left to the right. And if the line falls, it should be negative. All right, take a look at the next one. Do you know what kind of slope this one's going to have? Hopefully you said positive because it's traveling up. It's rising from the left to the right. So this is kind of like the old times. I have to go up 2 to get across from that point, so that's my rise. My run, I'm going right to 4. So 2/4, and again, we already said that's 1/2. It's going to be a positive 1/2, which makes sense because the line is rising. Last one of these, and no, that's not it. There's plenty more. Don't you wish? I need to get from point to point. When you look at this line, hopefully you see, this one's going to have a negative slope. It's traveling downward. And I think you're right. Let's try it. To get from, we'll start from here to here. Why not? The rise, I need to go up 3. When you travel up, that means positive slope. Now I have to go left. I go left 1, that means negative. When we simplify this, 3 divided by negative 1 is negative 3, and we're at the point where I'm just going to let you write it as a whole number if it simplifies to a whole number. But understand this does mean 3 over negative 1, or negative 3 over positive 1, which we'll talk more about in class. So nice little review of that. Only new thing, if you see a line that's traveling down, that means the slope's going to be negative. All right, turn your page. Now it's going to be our job to graph a line if I give you the slope and a point that passes through the line. So I give you 3 steps here. Step number 1, plot the point. And remember, when you're plotting an ordered pair, it's XY, it's not rise over run. Ordered pairs are XY. Then from that, we're going to use rise over run to create another point. So instead of starting at the origin where you're used to, we're going to use our slope to create another point, but we're going to start at the other point we plotted, and then Use a ruler to connect the points, please. Don't just draw your line. Use the ruler. Don't spin it around on your pencil or bang it on your desk. Just use it to draw your lines. I know we can do it. All right. So let's try it. I tell you the slope is 2/5 and the point on the line is -2, 1. So step 1 says let's plot our point. So again, remember -2 is the x-axis. So I'm going to move left 2, up 1. There's our ordered pair. Now, if I tell you that the slope of the line is 2/5, this +2 means we go up 2. That +5 means we go right 5. It's still rise over run. So from this point, I'm going to go up 2 and right 1, 2, 3, 4, 5. All you need are 2 points to make a line. Take your ruler. If you don't have one, press pause, go grab one. Welcome back. And there we have it. Right, take a look at the next one. Step 1, let's plot our ordered pair. So the ordered pair we're given is 2, 3. That means 2 on the x-axis, 3 on the y. Okay. The slope says -3 halves. Now if you recall in that example on the front page, when we had the negative, I'll put it up here and show you. When we had the negative in the denominator like this, I said at the end we just write it with the negative sign right in the middle. So if you see a slope with a negative sign there, this means that either the 3 is negative or the 2 is negative. Not both, because when you divide a negative and a negative, don't you get a positive? And this is not a +3 halves. So what I usually do is I put it with the top, or if I see that I don't have enough room to graph it on my graph, I would put it with the bottom. So let's put it with the top because it doesn't look like I can go up 3 from this ordered pair. So this is really going to be a -3 over 2 as our slope. -3 in the numerator spot means down 3, +2 in the, -3 in the numerator spot means you go down 3. 2 in the denominator spot means I'm going to go right 2. So start at your ordered pair that you just plotted. A slope of -3 means down 3 and then right 2. We have our 2 points that we need to make a line. Grab your ruler and connect the dots. Now another way to kind of check if this whole positive negative thing is throwing you off, if it says that the slope is a -3 halves, when you look at your line, it should be a line that travels downward from the left to the right. If your line's traveling up and you're given a negative slope, you've done something wrong. Go back and check it. Okay, next one. All right, I'm given a slope, I'm given a point. Let's plot our point. -3, -4 means -3 on the x, -4 on the y. Now, I know that you need a rise and a run to plot our slope. Do you remember when we just simplified this one here? So if you don't have to flip it, I'll show you the sheet. We had 3 over -1 and we wrote -3. All I have to do to get a denominator, if there isn't one, is put a 1 under it. It's kind of like when you want to multiply fractions and you have one of them's a whole number, you just put a 1 under it. That's it. So a slope of 3 means that you're going up 3, right 1. So from here, we want to go up 1, 2, 3, right 1. 2 points, that's all I need. I can draw my line. If I wanted to do more than 2 points, I could just keep going up 3, right 1, up 3, right 1. That's how you get from one point to the next on the line. All right, let's keep it going. This one, our ordered pair that we're given is 1, 3. So I'm going to plot 1 on the x, 3 on the y. I have a whole number slope again. Remember, if you have a whole number slope, to get the run, put a 1. So 1 on the top, that means the rise is 1. 1 on the bottom, that means the run is 1. So they're both positive, that means I'm going to go up 1, right 1, and draw my line. Ooh, I just made something very blurry. Let me do that. Let's see if I can fix that. Where is my... Uh-oh. Let's see. Auto image. Is it going to help me? I'm sure you can't see that, can you? Almost. I don't want to press pause yet. Ah, beautiful. Thank you for your patience. Sorry for the technical difficulties. Okay, next one. Aren't you glad you got a little break? Maybe I just knew you needed a little break. 0, -2. That means 0 on the x, -2 on the y. Again, whole number slope. Put a 1 under it. This time my numerator is negative. That means that I need to go down 2. My denominator is positive. That means I'm going to go 1 to the right. So from this point, we go down 2, right 1. Draw our line. And hopefully you notice, we just talked about it, this line is heading downward, which makes sense because it's a negative slope. It should head downward when it's a negative slope. All right, last one of these, and then yes, there's one more page. They're going pretty quickly, I hope. -5, 0 means -5 on the x, 0 on the y, so there's my dot. Okay, my slope here is -1/4. That means that either the 1 is negative or the 4 is negative. If I put the negative with the 1, that would mean I would have to go down 1, right 4. If I put the negative with the 4, that would mean up 1, left 4. Can we go left 4 and still be on this graph? Nope. So I'm going to put the negative with the numerator this time. And again, -1, that means I go down 1, that's my vertical movement, and I'm going to go right 4. So from the point that we plotted, down 1, right 1, 2, 3, 4. I have enough to make a line, so I will do that. If you want to make more points on it, go ahead. Just keep going with your slope. Down 1, right 4. You'll still be on that line. Okay. Last but not least, we have introduced you to our slope formula of y2 minus y1 over x2 minus x1. At this point, we're going to require you to use it. So you kind of see why it works, how it works. Now, without a graph, given 2 points, I want you to be able to find the slope of a line. So again, I have little steps for you. You can just follow along on the steps. I think that's very helpful. It's always a good idea to label your points. So if you're looking at the points that are given to you, I want you to, above them, write x1, y1, x2, y2. So that's step 1. Step 2 says, take y2 minus y1. That's your numerator or your rise. So I like to circle those. I'm going to circle my y's. So the change in y, again, that means I take y2 minus y1. y2 minus y1 in this case is 1. To find the change in x, that's step number 3, take x2 minus x1. And 4 minus 2 is 2. So the change in y is the top, change in x is the bottom. I'm going to check it for simplest form, and lo and behold, it is in simplest form, so I know that we are good. That's basically it. It gets a little confusing when you're trying to subtract negatives. That's where I see mistakes happen. It's with the negative sign, so just be cautious with that. All right, let's try the next one, and we'll go through those same steps every single time. Let's label our points, x1, y1, x2, y2. I'm going to circle my y's and underline my x's. So the change in y, I would take the second y minus the first y. 1 minus 2, yes, the keep change. Never forget it. 1 plus -2 is -1. The change in x's, I have to take the second x minus the first x. 2 minus 1 is 1. So to write the slope, I take the change in the y over the change in the x. Can that be simplified? It sure can. -1 divided by 1 is -1. You always want to give your slope in simplest form. Okay, we only have 3 left. Yay, we're just cruising along. Okay, label your points. x1, y1, x2, y2. At this point, if you feel like, hey, I know what I'm doing, I'm pretty good at this, why don't you hit pause, try to do these next few examples, hit play, and see if you're right. Or not, whatever. So welcome back if that's what you did. Congratulations. Going above and beyond. All right, y2 minus y1, that's what we're going to do first to find the numerator. That means I need to take 2 minus 4. 2 minus 4 really means 2 plus -4, which is -2. When I subtract my x's, and this is what I was talking about with the negatives, x2 is 1, and I'm supposed to subtract x1. x1 is negative 3, so I am subtracting a negative 3. Keep, change that, and 1 minus negative 3 gives you 4. So the rise, negative 2 over the run, 4 is what we get. I, of course, want that simplified, so I'm going to write negative 1/2. It's always best to leave your slope as a simplified fraction rather than changing it to a decimal, because generally you use your slope to graph points on a line, and if it's not written as a ratio, as a fraction, you're going to have to change it to 1 anyway, because you need the rise and the run. All right, enough said about that. Next example here, I'm going to label x1, y1, x2, y2. Circle my y's, underline my x's. So y2 is negative 6. I'm going to subtract y1, which is negative 2. It's another one of those subtracting a negative, which really means adding a positive when you keep, change. Negative 6 plus 2, that's negative 4. Now I'm going to subtract x2 and x1, so negative 3 is x2. I want to subtract negative 4. Be careful. Add the opposite, and a negative 3 plus 4 is 1. So the slope of the line, I take the change in y, which is negative 4, over the change in x, which is 1, and I can go ahead and write that as a whole number. Understand, though, that that does mean negative 4 over 1. So when you get a whole number, to get the run, you just put a 1. I think I'm going to make a poster that says that. Sounds like a fun little poster. Okay, last one. x1, y1, x2, y2. Circle your y's, underline your x's. y2 minus y1. It's 1 minus 1. That's 0. That's a little different. And now I'm going to take my x2 minus x1. 4 minus 1, that's 4. Or sorry, 4 minus 0, that's 4. And now, the rise is 0. The run is 4. Do you know what 0 divided by 4 is? It's 0. So if something has a slope of 0, I want you to try to imagine in your head what that would look like. Are you picturing a horizontal line? Yes. 0 slope means 0 steepness. We'll talk more about that in our next lesson. See ya.